My name is Liene, and today I want to talk to you about pretty unique and probably very niche problem, which is whether you should drink the whiskey you bought or whether you should leave it on your shelf and wait 5 years and sell it with as much as 1,200% profit. I personally lived in Scotland for 5 years, and I'm a big fan of whiskey, and I thought this would be quite a fun project to work on. However, one of the main issues with doing something like this, purchasing, leaving on the shelf, and then selling it, is that in general, here we go. Some whiskeys skyrocket in price, some of them don't at all. So here you can see two examples. On the top, you can see a bottling by Macallan. And if you bought it in 2013, you would have paid approximately £250 for it. However, if you decided to not drink it, leave it on your shelf, and then sell it off in an auction in 2020, you could get as much as nearly £4,000 for it. On the bottom, you can see one of my personal favorites, which is Ardbeg Ugadal. And please note the scale that the price does fluctuate, but doesn't really go up as much as for the top example. So you would normally, regardless of what year it is, you'd pay between 60 and £100 for a bottle of this. So when I thought about this, I was like, how could I solve this for my own profit, essentially? So the idea was that I would get past auction prices, combine them with whiskey features and my domain knowledge, apply it to a machine learning model and test quite a few things out, and just make profit. Super easy, right? However, as you will hear from now on, this very straightforward problem turned out to be a very not straightforward problem. So I started with data acquisition, for which I chose to web scrape online auction sites and retailers. In total, I web scraped 5 different auction sites and 1 retailer, which is Master of Malt. I scraped for winning bids, region, age, distillery, etc., whatever features I could get for the bottles, as well as for how much they sold at which time point. I used Scrapey, Pandas, and Fuzzy Wuzzy for string matching, and ended up with roughly 1 million price points from years 2011 to 2020, over approximately 50,000 items. I decided to split it and to train my model on 2011 to 2019 and actually test it on 2020. So as a little sanity check, I explored my data. There's a lot more exploration to do, but these are the few main things that I want to emphasize to you, is that if you look at whiskey auction market, it's very fast growing. You can see there on the left that from 2011 to 2019, the average winning bids have gone up significantly. And what was really cool for me is that you can even see Brexit, which happened in 2016. So the referendum happened in 2016, highly affected the market. The pound crashed. And you can also see that in my data. Secondly, I looked at the regions. So I personally am a fan of Islay whiskies. However, it turns out the most valuable ones and trending ones are Speyside. So that gave me an idea that I should obviously look at the region that whiskey comes from, so it differs. And one of the things that's probably not surprising at all is that it really matters how rare this bottling is. So if you look here at the very right, you see that if a distillery is closed, then you can really see that the price of the bottle really goes up. However, if it's operational, they're still releasing new bottles. The pricing isn't really going up as much. And from my domain knowledge, I knew that the older the whiskey is, the more valuable it's going to be. So as my baseline, I chose to predict the price on the median bid per age of the whiskey. And this is where my first issues with the data set started showing up, is that, as you can see, up until 30 years, it's quite steadily just increasing and there's not as much variation. However, when I look at older bottles, there's a lot of variation, and past 40 years, it kind of looks a little bit insane, to be honest. And this is because there are a lot less bottles in this age frame that are getting sold, and the prices, the bids also vary a lot more. So for my baseline, my mean absolute error, which means how much on average am I off in predicting how much the price should be, is 161 pounds, which is a lot. And by that, I've introduced one of my main problems is the data is skewed. So essentially, 75% of my data falls below 316 pounds in price. So obviously, these high sellers that I've talked about before are really difficult to predict because they're also just such a small data set in there. However, they are real data points. I have filtered my data a lot and I've looked at it and I can tell that these are real data points. So I can't really, like, getting rid of them would be essentially cheating. And also, arguably, those are the data points I'm interested in. I want those high sellers, so I need to leave them in there. Ordinarily, squares could outperform baseline, but roughly by 10 pounds, which again is not ideal. And if you think about it, then if my less, like, kind of younger bottles in general cost around 100 pounds, then this mean absolute error is pretty bad. So I thought that I could maybe solve this by stacking my models. So starting with Classifier, and for that I chose XGBoost after a couple of tests with other tree-based methods. And first of all, divide my data into exponential price increase, which would be these super high sellers. Linear price increase is just steadily following the market trends, and nose price increase, which are probably very basic, often seen bottlings that you could also buy in a shop, so there's no point in really buying it in an auction. Just because this question is probably going to come up, I also tried a binary classifier, which also didn't really work. So then the idea was classify and then use 3 separate regression models to predict these prices. When I looked at the accuracy of my classifier, it was really great. So it reached over 90% accuracy, super exciting. However, as I told you, remember, it's really imbalanced classes. So the maximum recall that I could get for this was about 66%, which was really suboptimal. And essentially, after a lot of experimenting with this, I decided that unless this is all I want to present to you today, I should leave it and move on. So my next question was whether I could at least estimate the current auction value of a bottle using XGBoost, as it performed really well on my data in comparison. And my regressor performs, and the mean absolute error has dropped to 63 pounds, which is good or really bad, depending on your perspective here. From my perspective, that's pretty great because what I worked with before was a lot worse. And essentially, by doing all of these experiments, I realized that my data is my biggest problem. Something that I would, every time I would fit a model, I would go back and do additional steps of cleaning, additional steps of feature engineering. And it just seemed that it's really difficult to integrate data from many different places where I scraped from. There are a lot of inconsistencies. There are a lot of things that you can't even filter out by a computer. I have to manually go through this data and realize that these cannot be real price points. One thing that did encourage me, as you can see in the feature importance graph, don't read through it. It's not important. The important point that I want to take you to take from this is that actually all of my engineered features were really important. So the domain knowledge helped a lot, and kind of just reasoning about it. So I don't think a person that doesn't know about whiskey as much as I do would be able to even get this good of a result, depending on your perspective again. Obviously, unsurprisingly, some of the most important features are things like the auction year, as I showed you from the how fast growing is this market. Interestingly, when I looked at my validation set, my model kind of underestimated the prices, which made a lot of sense because XGBoost cannot capture the trend. So it didn't know that during 2019, these prices went up. But when I ran the test set, my model ended up underestimating the prices, which was kind of weird for me and really didn't make sense. So I decided that I need to do troubleshooting on this. And what I found out was that, unsurprisingly, the market crashed in 2020. So 2020 has been a bad year for us, for all of us. All markets have suffered. Some of them have impacted positively, but this is not one of them. As you can imagine, single malt whiskey is a luxury, non-essential item that you can really live without. So people were buying a lot less whiskey, and they weren't willing to pay as much as they were willing to pay beforehand. Another thing that we need to keep in account is that Trump administration this year decided to put major taxes on import items, so to boost the US economy. Unfortunately, US is one of the biggest markets for Scotch whiskey. As I mentioned before, I obviously have unbalanced classes, which really affects the fact that my model isn't able to estimate the high sellers. And these are very rare and hybrid events. And again, I can't rule out scraping issues and the fact that I just need to re-clean my data a lot more and spend a lot more time on this. And honestly, there was just not enough time at the moment. However, I want to finish on a more positive note, which is that one is never done exploring their data. And I am still working on this with the cleaning and engineering and modeling and seeing if I can improve this somehow. I am experimenting with LSTMs, which currently are very vanilla. And I see some improvement, but not significant enough to really discuss this with you at the moment. I am also working on a dashboard because I think maybe my data is not really working for these predictions, but it might be nice to have a visualization. And as a person who really loves Scotland and single malt, this is something that I would like to produce. But don't forget, this market is fast growing and Corona might end, and we might be able to get lots more data that is more applicable to the model. And another thing that I didn't think about, and I really should have, was that I'm not working with retail prices here. I'm not estimating the market. I'm working with auction prices. And these do depend a lot more on other external factors rather than just the product you're offering. And with that, I would like to thank you for your attention. I'll be happy to answer any questions you might have. And if you want to discuss this, please get in touch on LinkedIn. I'll be happy to also share my code and insights with you. Thanks.